Welcome to topic number 10, percentages. The presentation of this topic will prove to be quite useful to students who are very skillful at working with percentages, as well as those who will deny that they know much about it. Many students can manipulate percentages without being able to give a reason why a particular approach is taken. After viewing this topic, students should be able to understand why certain steps are taken when solving problems that involve percentages. This lesson is designed to simplify a lot of the processes, giving students more efficient methods that they will find beneficial, especially in further work that involve percentages. If you consult the accompanying booklet, much detail will be given pertaining to the significance of percentages. If I may add at this point, of all of Richard James' mathematics resources, the booklets are my favorite and best documents. Consult them for extra clarification of the topics covered. Percentages are percentage of a specified value. As with all areas of mathematics, understanding the origin of a concept in percentages will cause it to be riveted in the brain with greater permanence. What do we mean when we ask the question, what is 25% of 80? A percentage is a fraction whose denominator is 100. We need to determine the number that will be placed over 80 in order to make the fraction equal to 25 over 100. So, what do we mean when we say, what is 25% of 80? Now, 25% means 25 over 100. So, 25 over 100 is a fraction that is going to be equal to something over 80. What is that something? Let's see. So we have something over 80, which is the unknown x over 80, is equal to 25 over 100. So this equation may be transposed, and we get what? This is divided by 80 on that side, multiplied by 80 on the other side. So that's what we'll get. So we'll see why this is highlighted in the long run. So we have x is equal to 25 over 100 multiplied by 80. And we know this. This is not anything strange, but I'm just showing you how the form came about. The fractions may then be reduced by 25, and then we are going to reduce by 4 into 80 is 20, so your answer is x is equal to 20, so the answer is 20. So find 60% of 75. This is the same as saying find a number which, when divided by 75, gives the same fraction as 60 divided by 100. So 60 over 100 is our percentage fraction, and something over 75 is equal to that. There we go. So this equation may be transposed, multiplying by 75 on the other side. We are dividing by 75 on the left. So multiply by 75 on the right. Right, and this is our highlighted fraction, which is what we are accustomed to. We know that when somebody asks us, find 60% of 75, we know that is exactly how we do it. But we are just showing how we arrive at such an occurrence from the ground level up. So we are going to reduce the fraction by 25. Hope I don't make any mistake this time. 25 into 75 is 3. 25 into 100 is 4. Good. And then we are going to be reducing by 4. 4 into 60 is 15. So 15 multiplied by 3 is 45, and that is our answer. When we are told to find 60% of 75, the large fraction represents our first step, which is this one. We always use this. We may proceed with that first step all the time, so we may do that all the time. The process on the left gives us an appreciation that this did not come from outer space. Some may make a mistake and write 60 over 75 times 100. We need not make such a mistake if we remember that 60 is the percentage and should be placed over 100. We are going to be looking at the percentage of a specified value. Now Now that we know the truth, we may use the traditional way, placing the figure that is given as the percentage over 100 and multiplying by the other number, just like the good old days. Let's go. Find 20% of 65, so we put 20 over 65 multiplied by 100. That's all there is to it. The fraction may be reduced, and 5 into 65 is 13, so your answer is 13. Find 90% of 380. So divide 90 by 100, then multiplying the result by 380, just as we have done. We are accustomed to doing this from a long time ago, but probably some of us did not know how we arrive at it. And that is what the previous exercise was all about. So the fractions may then be reduced by 10. Yeah, quite easy. We always say 0 cancel 0. And then, of course, can we reduce by another 10? Oh, we're going to be using 5. Oh, we are going to be using another 10. And then we are going to multiply by 9, and that is our answer. Now we're going to be looking at one number as a percentage of another. This time we need to express one number as a percentage of another. The following typical statement of a problem. So the following, what we are going to be seeing now, is a typical statement of the problem that requires us to write one number as a percentage of another. What is 18 as a percentage of 72? 18 as a percentage of 72. It is 18 as a percentage of 72. This time we do not know the percentage. This means that we do not know the number that we divide by 100. This means that we do not know the number that when divided by 100 is the same as 18 divided by 72. So we do not know the percentage. So the percentage is always the fraction whose denominator is 100. So we do not know the percentage, so we do not know the numerator of a fraction whose denominator is 100. And of course, that is equal to 18 over 72. Of course, we may transpose as usual x over 100. So we multiply by 100 on the other side. So we have x is equal to 18 over 72 multiplied by 100. We have it highlighted over here because this is typically how we progress when we are required to solve a problem of a similar nature. The fractions may then be reduced by 18. 18 into 72 is going to be 4. And of course, 4 into 100 is 25. So there we have x is equal to 25%. The answer is a percentage because, as indicated, the number required has 100 as its denominator. There may be a little twist to the way that a problem is stated, like this one. What percentage of 50 is 30? What percentage of 50 is 30? So what percentage? We do not know the percentage. That means we do not know the numerator. In this case also, the percentage, that is the number that is divided by 100, is unknown. It is saying what percentage. That means we do not know the number that goes over 100. And it is equal to 30 over 50. This equation may be transposed as usual, multiplying by 100 on the other side, and this is what we get. And this is how we usually solve a problem like that. Just write 30 over 50 multiplied by 100. That is the way that we generally solve the problems when we have them given to us like that. But I'm just demonstrating with these fundamentals how this expression is arrived at. The fractions may then be reduced by 50. Of course, 50 into 100 is 2. So we're going to multiply 2 by 30, and we get 60. And 60 is a percentage, must be written with the percent sign, because x is the number that has 100 as the denominator, so we are sure that x represents a percentage. We usually start the solution of a problem by writing the larger fraction as our first statement. This is our larger fraction that we are talking about. It is usually written as our first statement. When we are asked what percentage of 50 is 30, we just jump and we write 30 over 50 multiplied by 100, and then we write equal and we put the answer. There's nothing to it. This is the ideal place to begin. We are just making a little investigation to determine the reason why we do this all the time. There are two mistakes that are typical. One, dividing the 30 or the 50 by 100. This defies logic, as the percentage, which is the number that we divide by 100, is unknown. We may use the wrong number as a denominator, like placing 50 over 30. No brain teaser here. From primary school, we know that the one that we need to know the fraction of is written as the denominator. So we know that the one that we need to know the fraction of, that is the one that we write as the denominator. So we are looking at one number as a percentage of another. Let us finish up with two neat questions. Express 13 as a percentage of 21. The problem says of 21. So it is a fraction of 21. Therefore, we know that 21 is the denominator. Omitting the preliminary steps, we may proceed as follows. So 21 is the denominator. So 13 over 21 times 100. And of course, we are neglecting the preliminary steps. And we cannot reduce this fraction. So we are going to be just writing our answers as decimals. So that is 61.9%. What percentage is 64 of 85? So is the percentage, we say what percentage, that means is the percentage that we do not know. In this case also, the number that is divided by 100 is unknown. So it's the percentage that we do not know, and we progress like that. So what do we do here? We may reduce the fraction by 5. So 5 into 85 is 17, and 5 into 100 is 20. Of course, nothing else will reduce, no common factors, and our percentage is written with a decimal fractional part. Increasing or decreasing by a percentage. When increasing $500 by 20%, we are accustomed to finding 20% of $500 and adding the result to $500. We will not even bother to go back to primary school. Bearing in mind that the original is always 100% of itself, just add 20% to it. If we are going to be increasing by 20%, all we need to do is add 20% to the original. The original is always 100%. So we add 20 to 100, we get 120%. So we need to find 120% of $500. So 120% is the same as 120 over 100. And we will find this percentage of $500. What do we do? 120 over 100 multiplied by 500. No problem with that. We have known this from a long, long time ago, and we have reaffirmed the fact by our exercises that we have done not too long ago. This may be reduced by 100 quickly, and we have 120 to be multiplied by 5, and that gives us $600. If we found 20% of $500 and add the result to $500, we would have received the same answer. However, we have graduated from primary school a long time ago, and we need to graduate from the thought process immediately. We also need to take it another step further, as we will see as soon as we have completed a reduction problem. We are going to do a reduction problem. We have an increase problem. So we are going to have a reduction problem, and then we are going to take the increase and decrease a step further. So we know that we could have found 20% of 500, then add the result to 500. What we have done instead is add the 20 to the 100, get 120%, then find 120% of 500, and it works just fine. We are going to take it a step further, but let us do a reduction problem first. Mr. Brown weighed 250 pounds 3 months ago. He went on a meager diet and lost 15% of his weight. How much does he weigh now? So we are going to be reducing 250 by 15%. So how do we do that? His original weight is 100%. Losing 15% takes us to 85%. 100 subtract 15, 85%. We therefore need to find 85% of 250 pounds, which is 85 over 100 to be multiplied by 250 pounds. That is what we get. They may be reduced by 50. 50 into 250, that's 5, and into 100, that's 2. That turns out to be 212.5 pounds when we have calculated. When working problems using the method that we'll discuss next, students usually ask if they will get all the marks if they use such a short process. The fact is, examiners expect the students to work at the level of efficiency. So students should receive all of their marks. So increase 60 by 25%. The increase will make it to 125%. No problem with that. Remember that the original is always 100%. So we're going to add 25% to that, so we get 125%. So 125% is equal to 125 over 100. That is equal to 1.25. So all we need to do is multiply 60 by 1.25, and we get 75, and it's as easy as that. So increase 460 by 8%. Of course, if we're going to increase it by 8%, we're going to get 108%. What is 108%? 108 divided by 100. So when we divide by 100, what do we usually do? 1, 2. That's what we usually do. And we are going to get 1.08. So we are, right, that's it, 1.08. So we are going to multiply 460 by 1.08 and see what we get. So we get 496.8. Students will further increase their efficiency if they are able to arrive at the 1.25 and the 1.08 mentally. This will cause them to solve the problem in one step. So let's see if there's any such thing. Increase 400 by 15% is, say, 15% to be added to 100, it's 115. Divide that by 100, 2 places a decimal, 1.15. So we're going to multiply 400 by 1.15, and that gives 460. And the other one is done in the same way. We're going to decrease 300 by 18%. So what do? We take 18 from 100 because the original is always 100%. So we take 18 from 100, and we are going to get 82%. What is 82%? 82 over 100. 82 over 100 is 0.82. 2 places of decimal. So we are going to multiply 300 by 0.82 and see what we get. 300 multiplied by 0.82 is equal to 246. So that's our answer. Decrease 256 by 2%. If we're going to decrease by 2%, let us work it out mentally first. 2 from 100 is 98. Divide by 100, 0.98. So we multiply 256 by 0.98 in one line, and that is what we'll get for our answer. Let's see. (256) multiplied by 0.98, and that is all there is to it. Students should be able to arrive at their decimal mentally. This will help when working at the next subtopic, which is recovering the original, and compound interest and depreciation. So compound interest and depreciation, when we're working with those, the decimal representation of the rate is going to be very important. Decrease 687 by 30%. Good. So what do we do? Decrease by 30, that will give us 70%. 70 over 100 is 0.70. Two places of decimal, but the 0 at the end is unnecessary. So we may say 0.7. So at the end, we multiply 687 by 0.7. And that is all there is to it, 480.9. There's nothing to it. The owner of a cambio in Montego Bay approached me at the famous clock tower one morning. His daughter got a problem in which she was given the price of an item inclusive of GCT, and she was required to determine the price before tax was added. He was able to determine the answer to the question by using a mathematically legitimate method, but he needed to be able to outline all of the reasons to another family member who did not quite see it as he did. This is another one of our serious problems when working with percentages. When the thing is already increased or decreased by a particular percentage, and we need to go back and find what the original value is. So let us see if we can make a meal of the problem before we iron everything out the right way. So an item in a store costs $230 inclusive of a value-added tax of 15%. What was the initial cost of the item? So we have $230. That's what the price is. And the tax is inside of that $230. What is the original? Let's see. 15% tax. What some of us do. Since 15% was added, some student will attempt to solve the problem by subtracting 15%. So what they do, find 15% of 230 and take that away from 230. So let's do that. Find 15% of 230, then subtract that from 230. Okay, so what we have here is that the 15% is already taken away. We have 85%, which is 0.85, and we multiply by 0.85. So we are going to be using the most efficient method in order to determine that reduction. And we have 195.5, which is in dollars, so it is $195.50. If this were correct, increasing $195.50 by 15% will give us 230. Let us use our efficient method again. So we're going to use the efficient method to increase by 15%. And do not forget, increasing by 15%, 115%, divide by 100, 1.15. So we're going to be multiplying $195.50 by 1.15. And that is what we get. We got $224.83, which did not quite go up to our $230. Therefore, we know that something is wrong with our method. Therefore, let us come to a conclusion. When the value that we have reflects something that is increased by a particular percentage, we cannot decrease by that same percentage in order to get the answer. There's another method that we have to use. This is a disaster, as we did not get the 230 that we expect. The horrible experience that we had in working out the previous problem can be forgotten by following a few logical steps. Since tax of 15% was added to the price, and it is now $230, the original price being 100% makes the new price 115%. So the original price is always 100%, and that original price was increased by 15%. So that value that you have there, $230, is actually 115%. We may use this fact and recover the original. So let us do it step by step, step by step, step by step. So 115% is $230. This expression gives the new price as a percentage. What do we do now? We need to find 1%. 1% is found by dividing by 115. And after finding 1%, what do we do? This is our expression for 1%. So what do we do after that? We find an expression for 100%. Now, if this is 1%, how do we get 100%? This is 1%. So to get 100%, we multiply 1% by 100. So 230 over 115 is 1%. To get 100%, we multiply by 100. And that's our final answer. After finding an expression for 1%, we may multiply by 100 in order to get an expression for 100%. This will give our original price, since the original is always 100%. The process is really very simple. We know beyond the shadow of a reasonable doubt that $230 is 115%. From here, we need to find our way to 100%. This may be done in many ways. However, finding 1% and multiplying the result by 100 is one simple option. It is logical and it is straightforward, and it can be used so that every single person can see where we are going to. So we are going to try another. Mr. Brown's weight increased by 25%. If his new weight is 240 pounds, what did he weigh before? His new weight is 125% of the original, because that's what is reflected in his weight being an increase by 25%. So an increase by 25% causes the original to gain 25%. The original is 100%, so this is 125%. So now we need to find what is 1%. This tells us his new weight as a percentage of the original. So we need 1%. What is 1%? 1%, we divide the 240 by 125. Find an expression for 1% as usual. So we are going to find the expression for 1%, and then we are going to multiply that by 100, and we get 192 pounds. So the process is very simple, and it is just like the one that we have completed, and let's see how we progress in the long run. If this is correct, increasing 192 pounds by 25% will give us 240 pounds. So let us use a more mature move to arrive at our answer. What do we do? Increase by 25%, multiply by 1.25 as usual. And we get 240 pounds, so we are sure that we are correct. What happens if the value was decreased rather than increased? A discount of 12% was given off the price of a shirt. If the price of the shirt is now $55, what was the price before the discount? So then, 12% is gone, and the result is $55. Therefore, what we have now is 88%, and that is the $55. So, going down by 12% tells us that the new price is 88% of the original. And of course, we are taking it that way also. So, we're going to find 1%. So, let us go from 88% to 100% via 1%. So, we're going to find 1% first. So, if 88% is 55, then 1% is 55 divided by 88. And that is our expression for 1%. So, what do we do next? Multiply 1% by 100 and we'll get 100%. So, this is our 1% here, 55 over 88. 55 over 88 is 1%. So, we're going to multiply by 100 and we will get 100%. That's what it turns out to be. Right. So, let us do our little backtracking again to see if we end up at the right place. Yes, man. Decrease $62.50 by 12% and see if we get $55 in one step. So we are going to do that. How do we decrease by 12%? Multiply by 0.88. So $62.50 multiplied by 0.88, and that is our answer. Geronimo. Surely, with Richard James' mathematics resources, no percentage problem should take 3 to 4 steps to solve. What is the new innovation? There has to be one, right? Right. Let us increase 80 by 15%. Let us also use one step to solve the problem. So, 80 times 1.15 is equal to 92. So, let us use the word original and final in our equation. So, here we have an equation. So, we're going to use, this is what? This is the original and this is the final. So, original multiplied by 1.15 is equal to final. When recovering the original, we may make the original the subject of the formula by a one-step transposition. So, if we want to find the original, what do? We take the original here and multiply by 1.15 in order to get the final. So, now that we are multiplying, to get rid of this 1.15 to the other side, we will have to divide by 1.15. So, the original is equal to final over 1.15. It is as easy as that. Well, this should not be a very surprising result. In this last set of problems, the original was not given. We were given the final and were required to find the original. Initially, when we were increasing and decreasing by a particular percentage, we multiplied the original by the percentage written in decimal form. So when we are increasing or decreasing by a particular percentage, we multiply by the percentage written in a decimal form. So it follows directly that if we are given the final and we are required to determine the original, we should divide the final by the percentage that is written in decimal form. Well, that's not very difficult. Remember that when we multiply, in order to transpose, we are going to divide. And it's just a matter of transposition. So let us see if we can use that fact and solve some more problems. Consider one of our initial problems that we solved. An item in a store costs $230, inclusive of value-added tax of 15%. What was the initial cost of the item? We know that what we have there is 115% because tax was added and the tax was 15%. So 15% added to $230. So 15% and the original $230 is 100%. So 115%. So that $230 that we have there is 115%. In decimal form, that is 1.15. So then, if we want to go back to the original, we have to divide 230 by 1.15. Because in the initial stage, when we were increasing by 15%, we multiplied by 1.15. So now that we have the increased value already, we are going to go and find what the original was. So we are going to divide by 1.15. So the price, $230, is inclusive of 15% tax, which makes it 115% or 1.15 of the original. So let us recover the original by dividing 230 by 1.15 and see if we get the answer that we already know to be $200. There we go. So let us do the same with a problem that contained a value that represents a reduction of the original. A discount of 12% was given off the price of a shirt. If the price of the shirt is $55 presently, what was the price before the discount? Now we know that we have a discounted price. We know that it's 12% off. We know, therefore, that what we have is 88%. 88% is 0.88. So all we have to do is divide $55 by 0.88. 12% off gives 88% or 0.88. So let us recover the original by dividing the final by 0.88. We should get the same answer of $62.50 if we are correct. And we are indeed correct. Let's try a few problems. An item was sold for $3,520, an increase of 10%. What is the original price? So what is the original? We have the final, we need the original. It is what? Increase. We had an increase of 10%. So what we have there represented 110% or 1.10. The 0 at the end is not necessary. 1.1. Therefore, we have to divide that by 1.1. So 3,520 divided by 1.1 is equal to $3,200. Decreasing a number by 32% gives a result of 340. What is the original number? So then, if we decrease by 32%. So what is 32 from 100? That gives 68. Therefore, what we have there is 68%. We are going to go to the original. 68% is 0.68. So we divide by 0.68. Lovely. We get 500. No problem with that one. $63 is the result of increasing a price by 5%. What was the price before? So we have there $63, and that represents an increase of a particular price by 5%. So what was the price before? Now, increasing by 5%, what's that? 105%. Which represents what? 1.05. Don't say 1.5. Say 1.05 because it is 105%. So we're going to divide 105 by 100. In our mind, we are going to remove the point 2 places. So we are going to get 1.05. Therefore, our answer, we'll get that by dividing 63 by 1.05. And that is $60. 0.5% of our population was destroyed. It is now 39.8 million. What was the population before? We have a serious problem here. Well, not so very hard to solve. But that 0.5% needs some investigation. Of course, just take 0.5% because it says that 0.5% was destroyed. That means we are down to 99.5%. So 99.5% is what's left. So if we want the original, we'll have to divide by 99.5%. And what is that? That is going to be taking 2 more decimal places to the left, 0.995. So we are dividing 39.8 by 0.995. Lovely. 40 million square. Students should remember that recovering a number that reflects an increase of 20% is not done by reducing by 20%. The increase could have been done by multiplying by the percentage written in decimal form. Recovering the original may be done by dividing the number given by the percentage written in decimal form. So if when we are increasing or decreasing, we multiply by the percentage in decimal form, that means when we are going to go back to the original, we are going to divide by the percentage given in decimal form. If it is more comforting, a longer method was also presented in the lesson, so you may use that longer method also. I have seen on a CSEC multiple choice paper a problem telling students that a number was increased by 10%, then decreased by 10%. The candidate was then required to tell if at the end the final was greater than the original. The other way around, which is the original was greater than the final, or the initial and final were the same, or if enough information is given. Now that's a problem. Let's see how we solve that. Let us call the unknown number x and use our short method to increase, then decrease by 10%. So let us increase by 10% first, which is 110%, which is 110 divided by 100, 1.1. So let us multiply x by 1.1. We get 1.1x. So let us now decrease the result by 10%. So we have 1.1x, and we're going to decrease that by 10%. So 10% off is 0.9, or 90%. When we multiply 1.1x by 0.9, we get 0.99x. 0.99x is less than x. It turns out to be a fraction of x. The final is therefore less than the original. The result would have been the same if the decrease was done before the increase. Remember that if a number was increased by, say, 12%, the new result is 112%, or when we divide by 100, we get 1.12. We may recover the original by dividing by 1.12. If it were decreased by 23%, the new value is 100 minus 23, which is 77%. 77 divided by 100 is 0.77. To determine what the number was before, we divide by 0.77. Students are sometimes unsighted when they are told about an increase by a number like 2%. So it is 100 plus 2, which is 102. When we divide that by 100, we get 1.02. This they sometimes write erroneously as 1.2. Be careful not to fall in the trap. Working with profit and loss is a matter of applying what was learned with a bit of common sense. Is this too much to ask? A man bought an article for $400 and sold it for $440. What is his profit as a percentage? We first need to find the profit, which is the difference between what he paid for it and what he's selling it for. And that turns out to be $40. When a percentage is sought, the percentage is usually relative to the original, usually the cost price. This is always so unless otherwise stated. We need therefore to find the profit as a percentage of the cost price. It cost him what? $400. So 40 over 400 multiplied by 100, and that gives 10%. In earlier mathematics, a lot of formulae were given relating profit, cost price, and selling price. Others were given relating loss, cost price, and selling price. If this has not yet become an everyday thing for us, it should at least be practical. Recalling a formula is much more difficult than the ease with which we are able to manipulate these buying and selling situations at this stage. After buying a piece of machinery for $3,000, a man discovered that it had a significant fault. He therefore had to sell it for its actual worth, which turned out to be $2,400. What is his loss as a percentage? So the loss is the difference between what he bought it for and what he sold it for, which is $600. The loss is usually relative to the original, so the percentage you need to take it relative to the original. So 600 over 3,000 multiplied by 100, and that is 20%. A man desires to make a profit of 15% on every single item that he sells. For how much should he sell an article that he bought for $450? So you need to make a profit, and we may do that in one step. It is one of our favorite. Just increase the price of the item by 15%. This may be done in our usual one-step style, instead of going through those lazy, hazy days of summer. So what do? We take the 450, we multiply by 1.15, and that's all there is to it. Some problems require that candidates determine whether there is a profit or a loss in addition to calculating the profit or loss. What is our approach at this stage? I will not even touch it with a long stick. If I do, it will be an embarrassing situation. Mr. and Mrs. Green faced a significant misfortune with their Toyota Town Ace. Instead of parking it and allowing it to rot, they decided to sell it at a loss of 40%. If they bought it for $300,000, how much are they planning to sell it for? So loss percentage is given, and we need to find the actual loss. So find 40% of 300,000. So that's what we have there. 40% of 300,000, and we have 120,000. What do we do with a loss? What is a loss actually? This represents the amount by which the cost price diminishes. It incurred a loss and had to be sold for less than what it was bought for. So we are going to take away the loss. So we take away the 120,000 from the 300,000, and we end up with $180,000. The problem could have been approached by saying that 40% will be gone and 60% will remain. This 60% could have been written as 0.6 and multiplied by 300,000, and that could be done, and we could have our answer in one step. Now, here's something that should be quite familiar. A man sold an article for $50, thereby making a profit of 25%. How much did he pay for the article? Right. So how much did he pay for the article? Recovering the original. We know what we are going to do already. We know that we are going to do what? Remember now that 25% is already in the price. The price is therefore 125%. and we need to approach this as one of our recovering original. At this stage, and with the experience acquired in the lesson so far, this is a one-step problem. So we know that we have 125%. We know that it's over 100, which makes it 1.25. And if we are recovering the original, we need to divide by 1.25. So we have to have 50 over 1.25, and that is equal to $40. By selling an article for $7,650, a loss of 10% was incurred. What was the purchasing price? Recovering the original again. 10% off. Right, so that is the price that we have there. The selling price is $7,650, and it reflects that 10% is gone out of it. So if 10% is gone, we know that we are left with 90% to divide by 100. That is 0.9. If we are going to recover the original, we have to divide by 0.9, and that is what we are going to do there. So with the loss already experienced, the original, which is represented by 90%, has depreciated by 10%. The value that we have is therefore 90%, which is equal to 0.9 of the original. We may make our recovery by dividing the original by 0.9, and that is what our original is, $8,500.